we'll be taking up coordinate geometry. So the first one, let me just draw a plane. Supposedly there is this point which is maybe denoted by P, and there is another supposedly here, maybe anywhere on any of the quadrants. That doesn't actually matter. Obviously these two must have their own coordinates, so let me just take it as x1 y1, and let me represent q with y2. We will be learning how to find the distance between PQ. Because we'll be finding the distance between PQ, obviously that's referred to as the distance formula. Let me just write down the distance formula, then we'll talk about and learn about the application of that. It is x2 minus x1. I need to tell you here, it's not necessarily that you only take the first letter being x1 y1 or x2 y2. You can actually give any of the coordinates with x and y with x1 y1 x2 y2. So the next one is x2 minus x1 whole square plus y2 minus y1 whole square with the whole root. We'll take a few examples of the application of this distance formula to understand it better. The first example, let us take as a direct application of distance formula. Find the distance between any two points, supposedly represented by the coordinate 6, minus 8 and 2 minus 5. Let me, for it being the first question on coordinate geometry, let me just here write in rough if this is represented as x1 y1 and maybe this as x2 y2. Here, as I apply the formula, it can be written as x2 being 2 minus 6 whole square plus y2 being minus 5, and then minus of minus 8 will give me a plus 8 whole square. So this is giving me a minus 4 whole square plus a 3 whole square. So it is 16 plus 9, that's giving me 25, and root over of 25 is 5. So the distance between the coordinates given, maybe I name them as P and Q, to be 5 units. This is being the very simple and a direct application of distance formula. Now we take a few more examples how differently the formula can be used in different other ways. Move on with another question. I need to write down the question though first. Show that the points maybe 6, 9, 0, 1 and minus 6, minus 7 are collinear. Collinear, if you remember, how do you understand it in layman? Suppose I give this a name of A, this being B or this being C. Doesn't look good with thick lining. Let me just use a thinner one. Suppose this is A, this is B and this is C. If I have to prove these 3 points to be collinear, if I prove AB plus BC to be equal to AC, then I can prove that these 3 points are collinear. Though when we later on move on to learning more on coordinate geometry, we can also know how I can use the triangle formula, the area of the triangle formula, to find that these are either collinear or non-collinear. But for the time being, we will be applying the distance formula. To do so, I told you, we can take up AB plus BC is equal to AC. So let me first find the distance between AB here. For AB, I will be taking up x2. So let me assume this as my x1, y1, this being x2, y2. Or let us just keep this in mind and remove this writing. So it is 0 minus 6 whole square plus 1 minus 9 whole square. That is minus 6 whole square, that is 36. 36 and minus 8 whole square is 64. So 36 plus 64 is 100. So root over of 100 gives us a 10. We now find out BC. BC has the coordinates 0, 1 and minus 6 and minus 7. So minus 6 minus 0 whole square plus minus 7 minus 1 whole square. Minus 6 whole square is 36 plus minus 8 whole square is 64. That is again 100, which is giving you 10. Now let me calculate AC, wherein the coordinates are 6, 9 and minus 6 minus 7. So it will be minus 6 whole square plus minus 7 minus 9 whole square. That gives us some minus 6 minus 6 gives you minus 12 whole square plus minus 7 and minus 3 minus 16 whole square. So 12 whole square gives me 144 plus 16 whole square gives me 256. If you add both of them, I think you will be getting 400, which is 20. So if I replace the value or substitute the value of AB by 10 plus BC by another 10 and AC is given by 20. So we prove AB plus BC is equal to AC. That also simultaneously proves that the 3 points or the 3 coordinates given are collinear. Well, let us take up only few questions, just the questions, the variety or the type of questions you can take up on this distance formula. You might just come across them. Let us take up a question which show that the points A minus A and minus of root 3a and plus root 3a. Simply I write it as root 3a. It becomes easier for me to write freehand. They are the vertices of an equilateral triangle. Also it says find its area. Herein we'll simply discuss how to go for this question just without actually calculating it. Let me name them as A, suppose this is B, and suppose this is C. To find if these are the vertices of an equilateral triangle, we need to prove that the distance between all the 3 sides, that is maybe AB, maybe BC and AC, should be equal. So you first use your distance formula to find AB, then the side BC and AC. If you find all the three distances to be equal, it can prove that it is an equilateral triangle. Find its area. To find out any equilateral triangle's area, we apply the formula of equilateral triangle, which says root 3 by 4. Area is given by root 3 by 4 side square. Now you have already calculated the sides, which you will always find these three being equal. Suppose it is given by some x unit, this being another x unit, this being another x unit. So that is the length of each of the side of the equilateral triangle. That you replace here as the side, and I name it here as x, and solve the given formula, and that will give you your answer as the area of the equilateral triangle in any square units.